So hello viewers, welcome. I'm going to discuss a problem on rotational mechanics. The problem is based on the rear wheel drive car versus the front wheel drive cars. Okay. Now you know what a rear wheel drive car means. Uh, that means, see, if you look at the diagram of the car here, so there goes the front wheel and there goes the rear wheel. Okay, now in a front wheel drive car, what happens? See, this is the engine of the car. So from the engine of the car, the front wheel gets the power. The front wheel gets the power. That means the front wheel rotates. And how does a car move? Just let me draw the ground below the car. The front wheel, see, if you look at the lowest, the point on the front wheel in contact with ground. So let's name the point A. So point A is tending to move towards the left. So friction on the front wheel will act in the forward direction. So that is friction F, and this friction F uh, makes the car move forward. So this friction F is responsible for motion of the car in forward direction. So there you have this, you have the driver sitting here. Okay, now that's the front wheel drive car I have discussed, and let's look at the rear wheel drive car. So let us come to the rear wheel drive car. Here the power from the engine is transmitted to the rear wheel of the car. Now I am not going to go into the details about the transmission of the power, how it goes to the rear wheel. So suppose the engine of the car is at the front as shown in the figure. So somehow the power is transmitted to the rear wheel and the rear wheel rotates. And in same way, consider the point B. The point B is the point on the rear wheel in contact with ground that is tending to move there to the left. That means friction on the rear wheel is to the right. Friction F on the rear wheel is in the forward direction, and this friction F makes the car move, right? Now let's look at the statement of the following problem. Okay, so an important criteria in car design is the maximum slope that a car can climb. Consider the two cars similar in all parameters. Now one is a rear wheel drive car and the other is a front wheel drive car. Distance between the front and the rear axles is L equal to 3 meter. So I'll just show in the diagram what this 3 meter is all about. What's this L and where is this L? This is L. Okay, and mass center of the car is at H equal to 0.75 above the road. That means, let me draw the mass center. So there it is, the center of mass. So the mass center is at a height H above ground. Okay, now coefficient of friction between tires and the road is mu equal to 0.8. For simplicity, neglect mass of the wheels. Which car is better in accordance with mentioned criteria? What maximum uniform slope can the better car climb? That means you have to find out maximum angle of the maximum slope theta through which the car can climb. So I'll take the first case as that of the front wheel car. So that is a diagram of a front wheel drive car. The power of the engine is transmitted to the front wheel as I have discussed here. So obviously the friction on the front wheel is in the forward direction, and that is limiting friction, because see here also theta is a maximum angle. Theta is a maximum angle of the inclined surface of the incline that the car can climb without slipping. So we are considering the forces. Let us look at the forces. So suppose weight of the car be W, so that is W cos theta. perpendicular to the wedge surface or inclined surface, W sine theta parallel to this inclined surface, and the normal reactions N1 at the front wheel, N2 at the rear wheel, and for the front wheel the friction is mu N1 because we are as theta is that maximum angle, that means it is the limiting condition that the car moves, and as the car just moves, so at the rear wheel the friction will be zero. Why friction will be zero? That the car is just trying to move, so the car is at rest. We can consider the car is at rest, so the friction at the rear wheel is zero because there is no tendency of slipping, right? Now if it suppose the car would have moved upward with an acceleration, then the friction at the rear wheel would have been in the reverse direction. Okay, now see, in this case it is zero. So these are the forces. So N1, N2 and W weight we have split up into W cos theta and W sin theta and mu N1. Okay, and let us consider X and Y axis. So our plan is to balance the forces along X and along Y, and then balance torque about the point P. Okay, got the point P, that is the point of the rear wheel in contact with the wedge surface. So here are the equations, just go through the equations properly. So just what we said, our plan, balance force and balance torque. So balance force along x axis, balance force along y axis. So along x axis you get mu n1, that means the force mu n1 is equal to W sine theta. So that is how we get equation 1, and along the y axis n1 plus n2 is equal to W cos theta. And then after balancing the force we have to balance torque about P. So about P you equate the anti-clockwise torque and the clockwise torque. So about P, see, torque of N1 is N1 times L, and plus torque of W sine theta plus W sine theta into H, because due to N1 and W sine theta both the torques are in counterclockwise sense, and that will equal to torque in the clockwise sense, that is provided by W cos theta. So that is W cos theta into half of L. So from 1, 2 and 3, so what we are doing actually, we have to get rid of N1 and N2 and express, and so we substitute from equation 1 and 2 the values of N1 and N2 in equation 3. So here in equation 3 we have to substitute only from equation 1, that is N2. So there it is, W sine theta by mu times L plus this. So here it is. So after calculation you get tan theta is L by 2 divided by L by mu plus H. So tan theta is mu L by 2 times L plus mu H. So again similar thing we are doing for calculation for the rear wheel drive car. As you know, in the rear wheel drive car, the rear wheel is trying to rotate, tendency to rotate, so the friction mu n2 will act in the forward direction. Okay, and these are the forces n1, n2, mu n2, W cos theta, W sin theta. So our plan is again the same, balancing the force about balancing the forces along x and along y, and then again balancing torque about P. So that is the same thing I am repeating again, just for this rear wheel drive car. You see force, balancing force along x axis we get equation 1, along y axis you get equation 2, and balancing torque about P you get the equation 3, and then from 1, 2 and 3 the same strategy, get rid of n1 and n2 and replace n1 and n2 in terms of W and mu also. So from 1, 2 and 3 you get the following expression. There it is. So here after calculating you get tan theta is mu L by 2 times mu H minus L. So if you compare the values, you see tan theta is more. Tan theta is more in case of the rear wheel drive car. That means the rear wheel drive car can climb up higher slope in comparison to the front wheel drive car.